Hi there.
Yeah, hi George. This is
Hey, Rich.
Ohio, New York.
Hey, man, this amplifier had a catastrophic failure. What I like to call a catastrophic failure. These two transistors are smoked, and the way that these transistors were smoked, which you do see, but you don't. I don't usually see this a whole lot. But basically, the transistors were damaged to the point to where voltage was flowing through the transistor to the bias circuit. Same with the driver. This is probably the second or third driver I've had fail in a Texas Star since I've been repairing them. So I'm going to have to remove this whole driver section and put another one in. It honestly is not worth the time and labor to break this down and put a new transistor in. I've got some sections that are already put together and ready to go. That'll be a lot cheaper for you than me having to actually break this down and build it back up, because it's just, everything's just floating together, soldered together. So far it doesn't look like these two transistors over here are blown, but I can't 100% say. I don't know if somebody had been in here and tried to repair it before. The cap's missing from here. The cap was missing from right here, which I went ahead and installed the cap back right here. And there's just some other things with the amplifier. It looked like maybe somebody had tried to get in here and figure out. And also the 330 was missing from right here, and it was loose from one end right here. So I don't know. Maybe it got so hot that these things came unsoldered and fell off, or somebody has worked on it. But we'll get her figured out, man. We'll go ahead and remove this driver section right here and get another one put in it. And up to this point, I've got to get you 3 more transistors. Hopefully not all 5. Alright, I'll be back. Alrighty, Rich. All done, my friend. This took quite a bit of labor, man. Quite a bit of labor. Whew. This is one of them deals that where you get the amplifier working finally, and then you find out there's another mysterious issue going on that you got to track down. So, of course, as you already know, I found out these 2 transistors right here and the driver were blown. Luckily, these transistors over here were not, so you got lucky. Okay, so you had two good transistors out of the 5. So I went ahead and just dropped in a whole new driver circuit module, I guess you can say, a whole new driver circuit. Had to find 2 Toshibas to match these 2 right here, and I got very fortunate and found them. And after doing all that and finally getting it up and actually working, well, actually, you know what? I found 2 Toshibas and dropped them in, and they matched these 2 right here, and it just wasn't making the watts. And come to find out, which can happen, I've had this happen, but it's pretty rare. These transistors right here test good. So I had to write myself a little note. Test good, but low output. Test one at a time later. So I'm going to go through and test one of these at a time in circuit later and see if both of these are damaged and doing low output, or if just one. Very rarely, very rarely, you'll have a transistor to where it tests good on your computer or your test equipment, but it's actually either bad and doesn't work at all, or it's just doing low output. Because for one thing, it was doing low output, and I could tell there was an imbalance by the heat that was being the combiner resistor was trying to soak up. So I had to find 2 more transistors that matched, and I only had 2 more that matched. If I wouldn't have been able to find 2 more, I would have had to call you and would have had to figure something out at that point. You may have had to go ahead and replace all 4 of these transistors, but you got fortunate and didn't have to. That's all that matters. So anyway, while I'm sitting there testing everything, just about ready to do the video, this happens. The 10 microhenry choke right here goes up in smoke, and it scared the heck out of me because I thought it was the resistor on the combiner. Thought I'd done popped a pill or something. I'm telling y'all that there is hardly no letdown bigger than when somebody like me in my position gets an amplifier completely ready to go and has been spent hours of labor on the amplifier, and you go to test it for the last time or make a video and something goes wrong. That's honestly, at that point, that's when you have to just shut things down and come back an hour or two later after you've calmed down. But in this case, I knew it should have been a real easy fix, because just from my past Texas Star wisdom that's stored up in my head, and also my little Texas Star diary back here, whenever this 10 microhenry choke right here goes up in smoke, it's because of three main reasons. It could be more, but the three main reasons are: one, that this choke on this side, on the right side or the left, most of the time it's on the right side of the choke, is shorted against the frame up under the board. Two, most of the time it'll be this one, but one or two of these jumpers can have a short in it. Most of the time it'll be this one. And then third is the 100 picofarad metal clad capacitor, which is your output tuning cap under the combiner right here, has failed and is shorted to ground, because this does not need to see a ground. This choke is here for DC to flow through and to block AC. It's to let DC flow through and to block AC. This capacitor right here, and this inductor right here, both work together as a tag team. This capacitor right here is designed to block the DC that's flowing through here, okay? And this choke is here to block the AC that's flowing through to this capacitor. I always look at it like it's a person standing in the road directing traffic. DC, you flow through here. AC, you flow through here. But in between this point and this point, they're both acting as shields, blocking shields. DC, you cannot come past this point right here. AC, you cannot go past this point right here. So what happens when you key the amplifier, AC flows from the relay on this point right here that this is soldered to on the same path over to this capacitor, flows through this capacitor to this white part of the center conductor, this coax, and goes out. And then when you key it, DC flows from the positive coil on the relay, which is coming from up here on the switches, a positive switch up here, flows through this choke on the same path the AC is touching, then flows down the board to right here, which is where the bias circuit is, and also the circuit for your meter. So that's a quick lesson of what these two objects are doing. So which of the three was the issue? It was the first one. On this side of the inductor was touching ground, but not at all times. So that's why it was working for me, and then boop, it wasn't working. It went up in smoke. It was actually this side of the capacitor right here. This side of the capacitor right here. Some solder had dripped down, and was touching ground. And I can't see through the board because I didn't take the whole board out. You don't have to do that unless you just absolutely have to. So it was either this point right here or the path from here to here. My guess was it was this point right here. So basically I had to go ahead and fix that, put some insulators under the board, and also a adhesive insulator that I got from my buddy up at Texas Star that they use a good bit. Because over time these boards can flex. They can bend. When things get hot, boards can flex and bend. And it's just the way things go. And I was testing the amp out really good. I like to put an amp through a good burn test and let the heat sink heat up after I do a repair. Because just getting an amplifier working, you're only halfway there. Once you get the amplifier working, now you got to let the amplifier heat up pretty well and then cool back down. And as long as it heated up pretty well, cooled back down, and still working, you're good to go. Let it roll. Because you got to let things heat up. You want this thing to last while it's hot. So there you go, man. So we finally got it done for you. I went ahead and put all brand new 330s right here from collector to ground, so they all would match. The ones that were in here did not match. You got your power wire upgrade. I only got one wrap on these because this specific ferrite right here is like triple the permeability of 43. I had like 20 pieces at one time and used one on this. So just one wrap around this ferrite equals like 4 or 5 wraps around 43. Pretty cool, huh? Learn about induction. Inductive properties is really neat. So, all right, man. So, we have, go ahead and take this off. Just checking the bias before I keyed it up last. All right. So, we are running on 14.5 volts. Actually, 14.6 volts. All right. Go ahead and put it on high. Using a 4-watt radio, it peaks about 18 peak or so, 18 watts peak, 4 watts RMS, 1000 watt slug. This is on high. Oh yeah, a little bit under 300 bird. Oh yeah. Deck in about 180. All right. All right, what I'm going to do now is turn off my solder iron first. Take a look at the peak. See what this bad boy is doing. PEP. Oh, 700 watts. 700 watts PEP. So this bad boy is ready to rock and roll, man, finally. I tell you, that's one thing that sucks, is getting a box done and then having to work on it some more when you think you're finished. All right, man, I'll get the top put on this bad boy, get the screws in it, get it packaged up. I'll throw this smelly little thing in the trash. I still can smell that. All right, man, 73s to you, Rich. I appreciate you hanging in here with me too, bud. I know you had to wait a little bit on this thing, man. Your friend, Mr. Gatekeeper. Another Texas Star repaired. Out there 10-8 straight so somebody can get out there and do some talking. We'll see you. Bye-bye-bye.